So example 3 says, for a science class experiment, students must create a container that will prevent an egg from breaking when dropped from a height of 50 feet. So first thing it says, write an equation or write a function that gives the height h in feet after t seconds. So again, we're going to come down to our equations. This time we're dropping. So it tells us we're dropped it from 50 feet. So we know we're going to use the dropped equation. Okay, so the dropped equation tells us, oh my goodness, what am I doing? Tells us h of t is equal to negative 16t squared plus h of 0. So that's going to be the initial height that it was dropped. And we said it was dropped 50 feet. So let's just replace this with 50. And there's our equation. Now it says, when will the object hit the ground? So the object hits the ground when we're at 0. So that's the 0, or the solution, or the root, or the x-intercept. So whatever you call it, that's what we're talking about. So let's type it into our calculator. So again, I got to clear out my old stuff. So I've got negative 16x squared plus 50 this time. Okay, so it looks like too much time and not enough height. So let's change our window. So let's do negative 5 to 5. And it was dropped from 50 feet. So we know we need to go higher than 50 feet, or a little bit higher than 50 feet. So let's do 55. Oh, perfect. Okay, and it says, when will the object hit the ground? So let's see the zeros. So we know that the object will hit the ground on the positive 0, not the negative 0. So I don't even need to find this one. I need to find this one over here. So if I do my second trace, number 2 for 0, okay, and I need a left bound, right bound. I'm going to say 0 is my left. My right can be 5. And when it says guess, remember we just click enter. So it's at, oh, and I lost it. Uh-oh, I got to do it again. So we said 0 and 5. So I got 1.76, so it's going to be 1.8 seconds. So the object will hit the ground at 1.8 seconds. And we can even be more specific. It's not an object we're talking about. We're talking about a container that we created. Now the next question asks, find and interpret h of 1 and h of 1.5. So that means we are talking about time of 1 second and time of 1.5 seconds. Okay, so we have a couple of ways to do this. Time of 1 second we can find pretty easily because it's in the table. So if we go to second table, at 1 second we're at 34 feet. So it's 134. But 1.5 isn't in our table. So there's actually another thing we can do if you'd like to see it. We have to do second trace and this one that says value right here. So we choose value, number 1, and we just type in the x value that we want. So it's 1.5 seconds is what we want, and it tells us it's at 14 feet. So 1.5 is at 14 feet. Nice. So what does this even mean? It means that in half a second, the container dropped 20 feet. It was originally at 34 seconds, or 34 feet, now we're at 14 feet. So really, it was just 34 minus 14, which gave us the 20.